Hi, everybody. This is Chapter 9 Geometric Figures. I'm Alyssa.
I'm Faith.
I'm Chelsea.
And I'm Heather.
All right, let's get started on to question number 1.
All right.
Hey, Chelsea, what's a polygon?
A polygon is a figure that has 3 or more straight edges and angles. For instance, a triangle is a polygon. It has 3 straight edges and angles. Also, a pentagon is a polygon. It has 5 straight edges and angles.
Do you know what an n-gon is?
Yes, it's basically just a polygon, but the way you write it is n-gon, and the n just stands for the number of sides that the polygon has. So for an example here, you have a figure with 9 sides, so it's going to be called a 9-gon. Hey, Alyssa, what is a parallel line, and how are they relevant when talking about angles?
Awesome question, Chelsea. So parallel lines are actually lines that never touch. So these lines are going to be the same distance apart. So let's look at question 1 back from our lesson that we did last week. You see L1 and L2 right there. Those are actually parallel lines. And this is also showing us the corresponding angles property. This property states that if 2 parallel lines are cut by a transversal, then their corresponding angles will have the same measurement, like in angles 1, 5, 7, and 12. So that's pretty awesome. So hey, Faith, what's the shape inside of this cube?
Okay, let's take a look. Okay, as we can see, we're connecting all the lines inside of this cube, and we will find out that it's a tetrahedron triangle. Okay, tetrahedron models are 4 polyhedron vertices, and they have 6 polyhedron edges and 4 equilateral triangular faces. A polyhedron is a figure with a shape with many faces and usually more than 6. An equilateral triangle that is in the tetrahedron have all 3 sides that are equal. All the internal angles are congruent to each other, and a tetrahedron can also be identified as a pyramid, as we see to your right. Hey, Heather, looking at this concave polygon, how would you find the total sum of the angles?
So with concave polygons, there's a specific equation that we must first use to find the sum of all the angles. First, you need to count how many sides are with the polygon itself. So looking at this one, we have 8 sides. So the equation is going to be n minus 2 times 180 degrees. N is going to stand, is your variable for the sides. So you go 8 minus 2 times 180, which would then give you 6 times 180. So your sum of all angles inside this concave polygon equals 1080 degrees.
Awesome.
Chelsea, where on a polygon or a polyhedron can you find a vertex?
Okay, so first, does anybody know what a vertex is?
No. Can you explain that?
Okay, well, a vertex is where 2 rays are going to meet at a point. So now we're going to find them on the figure. And if you can see here on this first figure with the triangle, with the right angle triangle, I have marked the vertexes with a X. So where 2 rays meet is where you're going to have a vertex. And then again on this polyhedron, you can see in the black dots, that is where the vertex is located. Hey, Alyssa, what is the difference between supplementary and complementary angles? And how are these angles related to adjacent angles?
Awesome question. So supplementary angles occur when you add angles together to equal 180 degrees, and complementary angles occur when you add angles together to equal 90 degrees. And an adjacent angle occurs when you have 2 angles that share a side but do not overlap interiorly. So in problem 1, we saw many supplementary angles that occurred as well as adjacent angles, but there weren't any complementary angles in this problem. As you see, I drew red lines right here just to show you what an adjacent angle is. They never overlapped interior, so that's what we're looking at. All right, so Faith, what is the difference between an octahedron and an icosahedron?
Okay, first we're going to tell which one's which. To the left, we're going to see that that is an octahedron. First off, we know that octahedrons are an 8-face figure with 12 edges and 6 vertices. The figure looks like 2 triangles put together and their bases are attached, kind of like a diamond. Okay, the right will be an isohedron. The isohedron is a 30-edged to 20 equilateral triangles with 5 meeting places and only 12 vertices. Okay, as shown in our figures, you can see that the difference that the octahedron and between the octahedron and the isohedron is the octahedron smaller. Another way you can tell what an octahedron is and how many faces it has is because the octo means 8, and so octahedron means it has 8 faces. Hey Heather, what is the isohedron?
So the shapes you see on the screen have a few things in common. These shapes are called isohedrons. The most common one that I found was the soccer ball, which I really didn't even know that there was a different name for it. What sets the tetrahedron apart from the isohedron is the 4 plane faces that you get on a tetrahedron versus the 20 plane faces that you get on an isohedron. So, Alyssa, what is a reflex angle, and can you explain how you'd find one in a concave polygon?
I sure can. So a reflex angle is an angle that is greater than 180 degrees, but it's also less than 360 degrees. So if we want to find one in this concave polygon, first we must solve for all the interior angles. So first we must know the formula to find the sum of the interior angles, which is n minus 2 in parentheses multiplied by 180. So n is our number of sides, as you said before. So in this given problem, n equals 8. So then we must solve that, and the answer is 1,080, but our work's not done. After we get the 1,080, we have to set the sum of the measurements of the interior angles equal to the value of the measures and solve for y. So I've done that right there. As you can see, I've added all the sides together to get 54y equals 1,080. You divide both those sides by 54 to get y equals 20. And then we can find that 12y gives us a reflex angle of 240 degrees.
Awesome.
So, hey, Chelsea, what are complementary angles?
So basically what a complementary angle is just 2 angles that meet and they add together to get 90 degrees. And as you can see in the picture, it has a 50-degree angle inside of this right angle, and then at the top we have a 40-degree angle. And if you add 50 and 40, that's going to give you 90 degrees. So always remember, a complementary angle is going to add to give you 90 degrees. Hey Faith, what are supplementary angles?
Supplementary angles are angles that when you add the sum of the measures together they equal 180 degrees. As shown in our diagram, okay, we're going to use the angles 2 and angle 8. As you can see, they are supplementary angles because when added together, angles 2 and 83, and angle 3 both equal 180 degrees. Angle 2 being 100 and angle 3 being 80, it equals. But also in this diagram, there are more than one supplementary angles. Another one is angle 7 and angle 8. The degrees for both of them is 180, just like 2 and 3. Okay, so angle 7 is 100 and angle 8 is 80. So together they make 180. So both of these are supplementary angles. Just a little bit more. Angle 2 being 100 and angle 3 being 80, they are both supplementary, but also angle 3 and angle 7 could be supplementary, with angle 2 and number 8 being supplementary, because they all together equal 180. The 2 angles don't have to be beside each other to be a supplementary angle. They just have to equal 180 degrees. Hey, Alyssa, what are line segments and how are they used when dealing with angles?
Awesome question. So a line segment is a line that is distinguished by 2 endpoints. So when dealing with angles, we will use line segments quite often. So let's take a look at problem 2 from our lesson. We are looking at this triangle and we can see a couple of line segments. Lines PQ and lines QR, those are both line segments. So these lines further divide the shape and give us more angles to work with actually. Hey Heather, what does it mean if an angle is supplementary to another angle?
Next question. So Faith just kind of hit on this a little bit, but I'm going to use a kind of different example. When you look at this, you got two parallel lines with a transverse line, so you've got angles everywhere. When you have to know that a supplementary angle, like Faith said, equals 180 degrees. So in this example, you have angle A and the angle that is 61 degrees. So by knowing that it's going to equal 180 degrees, if you subtract 61 from 180, you're going to get 119. So it makes angle A 119 degrees because once you add them together, you get 180. Hey Faith, what is the difference between a concave and a convex polygon?
The difference between the two are that concave polygons lie in the measures of their angles. For example, to be convex, all its interior angles must be less than 180 degrees. For example, the diagonals of a convex polygon will all be in the interior of the polygon. The convex shape has no lines that curve inward. They curve outward. If they begin to curve inward, then they are concave. So as you can see, a convex is where they're all straight like this triangle. But whenever it's a concave, when the lines start to curve in, like in this diagram that looks like a baseball field, the lines start to intersect and bend in, making them a concave, like it's concaving in. Hey, Chelsea, what is the difference between an interior angle and an exterior angle?
That's actually pretty simple. If you just look at the word itself, the interior just basically means the inside angles of a figure. And then the exterior is on the outside. So any angles that are on the outside, like you can see here on the figure, it's going to be that line that kind of goes off of the shape. So basically what an exterior angle is by definition is that it is an angle between any side of a shape and array that will extend outside of that particular side. But again, like I said, it's easier just to try to remember it by interior is inside and exterior is the outside. Faith, what are corresponding angles?
Corresponding angles are angles that occupy the same position at each intersection where a straight line crosses two other lines. If the two lines are parallel, then they are equal corresponding figures. As shown, we have angles 3, angle 8, and angle 1. If we know that angle 3 is 80, and we know that angle 8 is 80, then we know that if we straighten these lines out, the angle 1 is also 80 degrees. Then we can know that when we send the lines of Q or PQ and RQ, we know that angle C and angle 6 are corresponding, knowing that 74 was angle C and 74 is for angle 6. So we both know that they're corresponding. They don't have to be beside each other either, like supplementary, just as long as they equal the same and they're the same type of degree. Angle 4 and angle B are also corresponding angles that we are using in our diagram, as in they're both 26. Hey, Alyssa, what is the difference between a concave polygon and a convex polygon?
All right. Before, but I'm going to hit on it again. So concave and convex are two words that, when not careful, they can be confused. A concave polygon is a polygon containing an interior angle or angles that are greater than 180 degrees. And a convex polygon is a polygon where all angles, all edges point outwards. So personally, when I see it, I think concave in my head means that something has caved in. So you can think of it that way. So the examples I've chosen is convex. All of those edges point outward in a triangle. And in the diamond shape, like the baseball diamond shape, like you pointed out, it's concave because those angles, the 12 Y's, go inward.
Awesome.
So, hey, Heather, what is the equation to find the center angle?
So we have a polygon here, and there's 3 angles that need to be found. The only one we're going to focus on right now is the center angle. So again, we will count the sides of the polygon we are given. In this one, we have an octagon, so we know that it has 8 sides. The equation to find the center angle is going to be 360 degrees divided by n. So you have 360 divided by 8, which is the number of sides of the polygon. And so the center angle is going to be 45 degrees. And you just, again, remember that n is your variable for all the sides on whatever figure you have.
Awesome.
Chelsea, can you explain what a polyhedron is?
Yes, it's actually pretty simple. If you break the word down into two different parts, you have poly and then you have hedron. Poly just is another word for many, and hedron is another word for faces. So if you put that together, it's going to be a shape that has many faces. Now, if we have just a regular polygon, that's going to be a two-dimensional shape. But if we have a polyhedron, it's going to be a 3D shape. So as our book says, each polygonal region has a face within the polyhedron. So if you look here, I've given you a tetrahedron up at the top, and you can see that each face is actually a triangle. So within each polyhedron, you're going to see faces of another shape, and for this one, it's going to be a triangle. And then at the bottom, you can see the next figure, and you can see all of the faces that are triangles. Those triangles are going to be the faces of the polyhedrons. Hey, Heather, if angle C is congruent to angle 6, what is the sum of angle 8?
Okay, so looking at this polygon, you have several triangles within it. We know that all the angles within a triangle must equal 180 degrees. So what does congruent mean? Congruent means equal to, which means that angle 6 is going to be equal to angle C, which is 74 degrees. So now that we have two of the three angles, we can take 180 degrees and subtract the 74 degrees, which is your angle 6, and the 26 degrees, which is your angle B. So this will make angle 8 equal to 80 degrees, because when you add them together, again, you're going to have to get 180 degrees. So Alyssa, can you show us how tetrahedrons and octahedrons differ?
I sure can. So firstly, what is a tetrahedron? A tetrahedron is a triangular pyramid that consists of 4 equilateral triangles, and it's also known as the simplest of the ordinary convex polyhedra. So the tetrahedron also is the only ordinary convex polyhedra that has less than 5 faces. And an octahedron contains 8 equilateral triangles, and so 4 of its equilateral triangles meet at its vertex.
Hey, Heather, what is the shape that's inside of the orange, or the orange inside of the cube?
So looking at this cube, you see that there's a triangular shape outlined. So, but what is this shape? You can look at all the plane faces of the cube itself, but right now we just want to look at the planes within the cube. This shape has 4 plane faces and is in the shape of a triangular pyramid. So what we learned earlier is that if it has 4 plane faces, it looks like a triangle or a pyramid, you're going to have a tetrahedron. Hey, Faith, what are line segments?
A line segment is a part of a line that connects with 2 points. It contains every point on the line between its endpoints. An example of a line segment includes any sides of an angle or a triangle or a square. When both segments end points are vertices of a polygon or polyhedron, the line segment is either an edge. An example of a line segment is PQ and AB. As we can see, PQ is a line segment because it goes from 2 points from line P to Q. And another one is point A to point B, where another line is because it's going straight across from one point to the other. Hey, Chelsea, what is the congruent angle?
Congruent angles are 2 angles that are the same, which basically just means they have the same measure. And in this figure here, if you look at line 1 or angle 1, 3, and 8, we see that they all are the same. They're all equal to 100 degrees. And that is it. I hope you guys enjoyed watching our video on geometric figures, and I hope that it helped you understand it a little better. Thank you.